On the back of your picture card, or over there, write your name, email, and phone. Let's do that right now. Give you a minute. And I'll get started with lecture.
Professor, move this over a little bit. I'm like right in front of the. I don't want to walk.
Your email.
That's it. Oh yeah, that's good.
Put your picture card back where you got it after you get that information on the back side.
You told me you put it right here.
All right, today is the repro unit. We'll begin that with the anatomy part. And we'll start with the male repro, but before that we'll kind of compare the development of the external genitalia for males or for females, and There's a sexually indifferent stage at about 5 weeks where you can't tell in a sonogram what's going to be what. But they highlight in colors structures that become external genitalia for men and for women, for a boy or for a girl. So they highlight the genital tubercle, the urethral fold, pink, and the labial scrotal swelling in yellow. So what we see is that in the male structure, if it's a male pathway, they'll have an inherited X chromosome from mom and Y from dad, and he'll then develop the genital tubercle will become the glans penis. The urethral folds, they'll fuse and they'll form the ventral aspect of the penis. And then that labial scrotal swelling will form the outpouching for the gonads, the scrotum. A female pathway, if you inherited X from mom and X from dad, the genital tubercle will be the glans clitoris. The urethral folds, they'll remain open for the vaginal orifice. And the scrotum in females is the homologous structure of the labia majora. These are the homologous structures for male and for female. Well, just for the external genitalia. Now, one muscle I'd like to point out is the bulbal spongiosis, because that is one sex difference we're seeing now. In the men, it fuses, but in the women, it remains open. And so that's kind of the muscle that underlies the skin in this region here. So I would just note it. Bulbo spongiosis is kind of the muscle in this region that forms ventral penis or just remains open in females. So those are the adult structures in this slide, and the page numbers are all from the Atlas of Anatomy that I use, the 3rd edition. Well, getting back to male development, that's the adult structures. The male development is shown here. Now the gonad ends up in the scrotal sac, but in development at around 7 months, it's the posterior abdominal wall, okay? That's what you see up here. So let's talk about the descent of the testes. So the testes in the top of the figure are located in the posterior ab wall. And when they descend, they don't do so by themselves. They're pulled down by a structure called the gubernaculum. It's a little connective tissue thread that's right here. Gubernaculum. So it's pulling the gonad down out of the body cavity into the scrotal sac. The gubernaculum pulls testes through the inguinal canal into the scrotum. So it's really the inguinal canal, how the testes gets out of the abdominal cavity into the scrotal sac. Now, one thing I want you to notice is if it's behind the parietal peritoneum, the pink line, okay, and as you pull the testes down into the scrotal sac, you're pulling down a piece of the parietal peritoneum with it through the inguinal canal. Okay, now it pinches off right there, and a part of it remains covering the anterior aspect of the gonad, of the testicle, and it's called the tunica vaginalis. Okay, this double-layered sheath. It's a covering for the testes. So you pull down parietal peritoneum, a piece pinches off, covering the anterior aspect of testes. Okay, and that covering is called tunica vaginalis. So what I want you to know is this covering. It's a double layer, tunica vaginalis. It's derived from parietal peritoneum. It got pulled down with it. And you know that it only covers the front because the testes was behind it. So it doesn't go all the way around. So don't let the term confuse you. Men have a vagina too, right? Vagina means sheath. So it just covers the testes. All right, sagittal section. So let's get to the adult anatomy. And here's the sagittal section. That's a good view. You can kind of see everything we're going to talk about for male repro. And I put a couple other pictures in here too, because when you do a sagittal section, you're cutting right in the middle, and you cut right between the two testicles. So I put one in there. That's testes epididymis. The other thing that you can't see from the side view is the inguinal canal. So that is shown here, because remember, you had to pull the testes down into here. I mean, they went through there. And so in the inguinal canal, we'll talk about the spermatochore, because it can't just be there by itself. It needs a lifeline. You need blood supply. You need the duct that carries the sperm. You need nerves. You need lymphatics. You need everything else that any organ needs. So we'll talk about contents of the spermatochore. So a good overview to teach students what the male contribution to human reproduction is what I call people call it the 3 E's. Which is erection, emission, ejaculation. In a nutshell, that's the male. That's how the male helps reproduce. We have to talk about the female next, but that'll be Friday. So just to define the words. An erection is when the penis becomes engorged with blood. And when that happens, well, that's an erection. Now, the thing is, the physiology part of that. This is a vasodilation event. The arteries open up, blood rushes in, that's an erection. So erectile dysfunction is when that fails to happen. And so all the drugs you see, Cialis, Levitra, Viagra, they all work in the same way, where they increase the availability of cyclic GMP, and that'll increase the availability of nitric oxide, NO. That's important. That'll allow vasodilation not only in this region, in any region. Okay? So nitric oxide is important to know for the physiology. And so when you have that happen in the smooth muscle for the penis, it becomes engorged in blood. And I'll teach you 2 erectile bodies. Okay, now if you look at the penis in the cross section, all the purplish tissue is this highly vascularized smooth muscle that becomes, it just soaks up the blood during an erection. Okay, the next E, you achieve erection, is emission. That's where you have to, it's movement of sperm up to the urethra. Movement of sperm up to urethra. So I have to teach the male duct system. Well, now I could just say, people know that sperm are made here in the testes. The urethra is right there. It starts in the prostate. So you got to get from, you're outside the body cavity, the sperm have to swim all the way up to there. Okay? So then to get out of the urethra, that's ejaculation. Movement of sperm out of the urethra. I'm going to point out the urethra one more time. It's a conduit that shares, well, not at the same time, but semen and urine. You kind of go out that too. On the male, on average, is about 8 inches long. So there's a blank figure you can study, and we're going to go through all the structures. But I wanted to take a picture of a model that we have. It's on the shelf behind me. And we have models that just look just like the pictures. Okay, and I try to emphasize to students that when you have your lab time, it helps to know the picture before your lab time. I'll give you some lab time to study the anatomy on Friday. And if you come not having mastered the material, in other words, you know the picture flat. You can name everything that I've talked about. And you come here and you know everything. It's just a matter of confirming what you know. If you're trying to learn as you go in lab, you're going to be very frustrated and stressed out. Just trust me on this. I see it every semester. So you try to learn, it's loud, you can't get your hands on it. And, come prepared for lab, you'll feel a lot better about the situation. All right, the first thing I'd like to talk about is that inguinal canal. I don't really talk about it for females, but I do for males because the spermatocord goes through there. And so you have pictures in your atlas that kind of dissect away the layers. And in doing so, you can kind of see how the spermatocord, the coverings for it, are formed from these layers of the abdominal wall. Well, for men, if you've ever had a physical for sports, the doctor has to check for a hernia. So he sticks your finger in this area and he says, turn your head and cough. He's checking for a hernia. A hernia is when a loop of intestine bursts out of your ab wall. So if it's going to do that, it's going to take the path of least resistance, usually out this opening right there. Okay. So if you remove the skin, get all the way down to the muscle layer. This is the external abdominal oblique. It's the outermost layer of the inguinal canal. So a canal, you know what a canal is, it's a space. So this canal in the groin region is the canal through which the spermatocord enters and exits the abdominal wall. It's a canal through the ab wall. The spermatocord passes through here. I'll just say it passes. Now you can see the opening for the spermatocord right here immediately. That opening in the external abdominal oblique layer is the superficial inguinal ring, so note that. So you got external, external abdominal oblique, note the opening called superficial inguinal ring. You can see the spermatocord coming out of there. Now also know that the cord just doesn't pass through the opening. It actually takes connective tissue fibers from this layer as a covering for it. And that is called the external spermatic fascia. It's not on the figure, but note external spermatic fascia. Fascia is a covering. It's the outermost covering of spermatocord. Covers spermatocord. It's derived from this layer. So that's the name of the structure, external spermatic fascia, as well as the superficial inguinal ring. Okay, so if you remove that outermost layer and get to this deeper middle layer, it's the internal abdominal oblique. Now this layer, the spermatocord will take with it muscle fibers that kind of cover it. And it's called cremaster. So muscle fibers from this layer form cremaster. So cremaster is skeletal muscle. And the function is called the cremasteric reflex, which draws the testes closer to the ab wall for warmth, like when you're wading through a cold pool of water. So cremasteric reflex draws testes closer in response to cold. So I'll give you one function there. It is muscle. Now if you peel away to the innermost layer, that's the transversus abdominis. Now that layer, there's some connective tissue called the transversalis fascia, right here. Well, anyways, from that transversalis fascia, you get connective tissue that surrounds the spermatocord, and it's called the internal spermatic fascia. Transversalis fascia. Okay, so that forms the internal spermatic fascia. So just to recap real quick, I've outlined for you 3 layers that surround the spermatocord as well as the testes. So just to underline it again, external spermatic fascia, cremaster, internal spermatic fascia. And remember the layers that they're derived from. So the tie, ice, is, so the T is transversus abdominis, and I guess my I is, you know, the internal spermatic fascia, and then cremaster for the C, and then the internal, if that helps you remember. EE. That's what I was going for there. When I put the pictures side by side, hopefully you can tell it's deep to superficial from left to right. Okay. There's other pictures that show this region. This picture shows, actually before I move on, let me point something out I forgot to mention on this slide. If you have a superficial inguinal ring, you also have a deep one. So this one further back, where they have the green circle, that's the deep inguinal ring. It would be through this deepest layer. So add on, deep inguinal ring is something to know. What they do here is they show you all 3 layers right there. External spermatic fascia, cremaster, internal spermatic fascia. They even give you a cross-sectional view of the cord. And this is the outermost opening, the superficial inguinal ring. Okay? Now compare that to some of our pictures there. The inguinal canal would be this opening here. I mean, it's only like 2.5 inches. It doesn't take very long to like puncture through your ab wall obliquely like that. From a superior view, it's right there. If you look at what's inside the spermatocord and talk about its contents, this figure that I showed you before is useful. The most important thing is the blood supply. Okay, so the blood supply branches off the abdominal aorta. They're the gonadal arteries. Okay, so in the male, this artery way up here in the ab cavity is going to go through the inguinal canal, and it's going to end up within the spermatocord right here. So you should know, you should be able to identify that artery in the spermatocord. So know the spermatocord contents. The most important thing, testicular artery. Little a dot is my abbreviation for artery. Artery supply oxygen-rich blood. In this case, the testicular artery is a branch off of the abdominal aorta. Well, the other things in there, I'll just have you know the testicular veins as well. You have many testicular veins. VV, abbreviation for veins. Many veins. Cool off the blood in the one artery. Okay, so arteries and veins, when they run together, blood is flowing in opposite directions. If you have one testicular artery, it's taking blood down to the testicle. That blood is a little bit warmer and the blood being returned by the veins that run right next to it. So there's a bit of a heat dissipation. Think of the veins as being a heat sink. There's many of them, they surround it. Blood's going back the other way. There's this kind of counter current exchange, whereas the cooler blood is flowing back, is taking away some of the heat of the hot blood. So it's a proper temperature when by the time it gets to the testes. Okay, you can also call the testicular veins pampiniform plexus. Term is on the slide. Another alternative name. Pampiniform plexus. Well, most students prefer testicular veins. It's a lot easier to remember. Now, the most important structure in the spermatocord is the ductus deferens, because that is transporting the sperm. Ductus deferens. The ductus deferens is about 18 inches in length. Not very long, but it's the tube that carries the sperm during emission. Okay? There's nerves and lymphatics in there. I won't give you any of those to know. Pretty much the artery, the vein, and ductus deferens. I'll keep it simple because the coverings can get kind of dicey. Now, if you look at the picture on the right, the picture of the model, you kind of learn what they're trying to show you here. This side is a deeper dissection, so you can see the artery, the veins, and the ductus deferens are in there. Now, they illustrate many arteries. My understanding is there's only one. But if it's a red structure, the model makers are trying to show you this is where the testicular artery is. So anything that's colored blue here is a testicular vein. Now, that right there is the ductus deferens. It's hard to see. On this picture, the one that's not cut open, those muscle fibers are cremaster. Okay, and they do look like individual fibers. They don't form a full muscle layer. Okay, but it counts as a layer, and you can see them as individual fibers here. So all the gray that's underneath it will be the internal spermatic fascia. So what I did was I took a picture that's a little bit closer, and I tried to label it for you so you can study this at home. So when you study it in lab, you already got it down. Cremaster, internal spermatic fascia. The external spermatic fascia is the other side. They kind of go gray, red, gray. So it's very nuanced. The outer gray is the external spermatic fascia. The inner gray is the internal spermatic fascia. And the red line is supposed to be cremaster. Okay. When I did this dissection on a human cadaver, I tried to like grab and pull. And in pulling it, I tried to look for individual cremaster fibers, and I could see them. So this is a pretty good model representation. All right, the model shown here is in one of our cabinets. What they do is that when they cut their testes, they show you this layer here. That's the muscle layer, cremaster muscle. And this tunica vaginalis is also shown on this model here. So I just tried to like find what our models show, and I'm trying to show you in the lecture. The other way you can study the spermatocord is in a cross-sectional view. So what I did was I took a picture. I took a picture that I took, I can't remember when, a few years ago. This is from our collection. And I put it next to the artwork, and I just labeled it. Okay. I think you should be able to tell the artery. One artery, right? Just one. And in blood vessels, for the spermatocord, the artery is the bigger one, and it has a thicker vessel wall. It's surrounded by smaller blood vessels. They're all veins. Here's the one that's the most important. I always say most important because in repro, the most important thing are the sperm. So ductus deferens, be able to identify that. Here it is. Again, there's other layers here too. I usually don't see cremaster, they're kind of faded out there, but I usually always have students try to identify the internal spermatic fascia. That can also be seen. Okay, again, arteries, one artery, many veins, and the ductus deferens down here. It's pretty obvious. It has a columnar epithelium and sperm in the middle. Okay, it transports sperm. It's right there. It's a little blurry, I know, but one thing you should note is the vas deferens, or ductus deferens, it has many layers of smooth muscle. You write that down. So vas deferens, ductus deferens, same thing. Okay, many layers of smooth muscle, note that. Smooth muscle present. And the epithelium is a pseudostratified columnar ET with stereocilia. Stereocilia are for beating the sperm along the way during emission. So I'll be able to recognize that epithelium. Let's move on. Let's talk about the scrotal layers. It's kind of like rementioning the ones I already taught and adding some more. So in this picture, they're trying to tease away all the layers down to the testicle. And so there are many layers. It's not just skin, then testes. Okay? So what we see is call this scrotal layers. Just go from outer to inner, skin. That's the outermost one. The skin of the scrotum. Now, deep to that is a whitish, smooth muscle called the tunica dartus. It's right here. They put a pin underneath it, separated from the skin subcute. That's the next layer you should be able to be aware of. Tunica dartus. It's smooth muscle. It kind of gives the scrotum that wrinkled appearance. Okay, well, deep to that are the layers that we talked about because they cover the spermatochord as well. External spermatic fascia, I'm looking right here. Then it goes cremaster, and then it goes internal spermatic fascia in that order. So from outer to inner, external spermatic fascia, cremaster, internal spermatic fascia. Well, now you get down to the testes, and you have that double layer tunica vaginalis. They pull back the outer layer there. So that's your tunica vaginalis, the parietal layer. The whitish appearance is the tunica vaginalis visceral layer, so note that. Tunica vaginalis, you are responsible to know the parietal layer as well as the visceral layer. Parietal is always the outer layer, visceral is always the inner layer. Viscera always means contents. So the visceral layer is like always the layer that's on the organ. In this case, you know, testes epididymis. All right, so that's kind of as deep as you get, you know, all the way down to the gonad there. Now, if you move on to this figure here, where they cut all the way even through the testes, and they kind of like zoom in on this here, so you can kind of see the layers. Let's review them. I'll number them off. You got skin, number 1. So it just goes in order. 2, an external spermatic fascia, 3, 4, 5. Tunica vaginalis is like an AB, right? So let's go 6. A is the parietal layer. B is the visceral layer. You can even go one more layer deeper. That's the tunica albuginea. Okay. It's another whitish layer. Tunica means shirt, like layers of shirts. Tunica albuginea. Basically, that term means white layer. It's the deepest one. However, that layer is not just a layer that covers. It invaginates. It kind of shoots in. So if you look right here, where it shoots in, here it's just covering, but here it shoots in. So all those little white invaginations of the tunica albuginea, just call them septum, and those septum form little compartments within a testicle. Let's see, I'll say the invaginate inwards. Forming septum. The septum create little compartments within testes. Well, those little compartments, those little, I think they're called lobules, those contain the sperm, the seminiferous tubules. So little compartments, lobules, contain, let's say, I think it's a 1 to 4 seminiferous tubules. Each tubule is very long. I've read they can be like something like 32 inches in length, just one of them. So they're all coiled up there, and we've seen them. That's where the sperm are made. But anyways, this is more meant to teach you just the layers leading up to that. If you look at the testes and epididymis, there's not much to look at. The epididymis, it's continuous. It's going to receive the sperm that have been produced by the testes. There's a head, body, and tail. Okay. So let me erase this. Epididymis, D-I-D-Y-M-I-S, means on top of the twin. Didymis means twin. Now, it looks small, but there's a head, body, and tail, and there's like a 21-foot long coiled tube that's coiled up in there. So it's densely packed. So note, head, body, tail. So 21 foot long tube. So this is where you can kind of store and sperm can mature. That's its function. Sperm storage / maturation. Sperm can become more motile. They can swim a little better during their residence time in the epididymis. So if you cut it open, it's one tube, but it looks like many cut tubes because it's all like coiled together. And so what you see there under a low magnification, you can kind of make out that it's going to have a columnar epithelium, and there's like sperm in most of these lumens here, okay? Indicating that yes, you do store sperm here. I did a close-up view. This is a 400x, and I want you to be able to identify the epithelium, which is, well, it's the same as vas deferens. Pseudostratified, columnar, ET, epithelial tissue with the stereocilia. And you can see the spermatocytes are right in the middle. Lots of sperm. And if you do a side by side, how do you tell the difference? Well, smooth muscle present. There's no smooth muscle here. That's connective tissue. That's kind of why I had to write it prior. Smooth muscle present for the Ductus deferens. So I want to move away from that to the penis. Okay, shift gears here. And let's learn about the perineal region before we even discuss the penis. So this region is defined, that's where all our external genitalia are, for males and for females. Let me define the region. Perineum. It's a region that's defined as the region between the thighs and the buttocks. So it's the region between that. So it's not that, it's between that. So look at the drawing here. They kind of draw the region like this. Doesn't it look like a bike seat? Yeah. When you ride a bike, that's the region. Okay. All right, so I have this picture over here because I want you to know that muscle. Now, this perineal region, they call that the UG triangle and that the anal triangle, even though it's drawn as a half circle. Any cyclists, avid cyclists? I had an elite cyclist in my class once. He could finish top 10 in any national race, or at least that's what he told me. That's one way to sterilize yourself, right? Just crush your perineal region, sit on that little bike seat all day. That'll do it. Or just snip the vas deferens. Right, getting back to this, definitions, UG triangle. Well, if you dissect the skin away, all the way down to the pubic arch, you're left with this diaphragm. The diaphragm is called the UG diaphragm. Diaphragm means membrane. And the membrane, the muscle of the membrane is the deep transverse perineal. So it's the muscle that creates this membrane. It spans the width of the pubic arch. Deep, transverse, perineal. There's superficial transverse perineal too. Superficial transverse perineal. Well, I'll point them out in the picture. So this region, the one that kind of like, the fibers run transversely across the pubic arch, that's the deep transverse perineal. The one that's more like a band that's superficial. So find those on models, be able to identify it. It's important to know because this is like a platform for the penis in males. Now this picture comes from a female. Now, how do I know? What's the clue? I see two holes. One's for the urethra. What's the other one for? Vagina. Okay. So for males, how many holes would there be? One, because men don't have a vagina. People know this already. So those are muscles. I taught that because you have to understand the urethra has to pierce that membrane. So this deep transverse perineal muscle. So I guess what I'll write as a note is urethra must pierce this membrane. All right. 1 for an hour, that's good enough.